Okay, so it's just gone 10 o'clock. I'll leave it for a couple of minutes as I introduce myself and the general context of today's meeting and welcome you all. Um, my colleagues are keeping an eye on the um, lobby, so I'll start sharing my screen and introduce myself uh, to start off the first Centre for Safe Air in collaboration with World Health Organization and Collaborating Centre on Climate Change and Health Impact Assessment, Hacky Hour, which is one of the services that is provided by the Centre for Safe Air's CARDAT, Clean Air and Health Research Data Analysis Technology platform, which I help to manage in my role as the director of the WHO Collaborating Centre. So as I said, that's me, Ivan Hanigan, and I wanted to acknowledge the country on which we live and work. I pay my respects to the Whadjuk Noongar Nation over here in Perth, and especially the past, present, and future leaders of the First Nations people, also on all the country that you're dialing in from today. So as I said, the WHO Collaborating Centre has taken on a leadership role with the CARDAT platform. Ever since I used to work, before I came here, I was at the University of Sydney leading the development of the CARDAT platform for the previous incarnation of the Centre for Safe Air, called CAR. And now that I'm collaborating from across the other side of the country, we have really pushed towards providing services to do environmental health impact assessments more generally, and to make these as data intensive and evidence informed as possible. And so I want to point out that everything that you're able to access today through the training will be available from our training site. And I'm going to be fairly interactive today and show you things as I go through the things that are on my computer. And so all these links will be available. You can find out. The most important link is cardat.github.io. That's the main landing page for everything to do with CARDAT. And you can see a link to my website where you can find the workshops under resources, and then a list of all of the workshops that we've held so far this year. And this today has this set of instructions and materials that you can download. So the title of today's talk is the NAPMD, which stands for the National Air Pollution Monitor Database. And what we've done over the last few years is to develop this database, which is the first of its kind in Australia. It's also one of the only examples in the world for a federated collection of states and territories to come together in a harmonized and standardized system. And it's been working as a database server for several years, hosted by our colleagues at the Terrestrial Ecosystem Research Network, which is a large national funded organization under NCRIS. But recently, in additional collaborations, especially with Dr. Grant Williamson at University of Tasmania, we've put an API front end onto this database, which increases its usability and the ease of use quite a bit. And so that led to this. We've been rolling out the access to the database backend for quite some time, but it takes more knowledge about how to use databases. And so the API takes a bit of that extra knowledge away. We'll be giving you access for today only using a temporary password and username that we've given you. But for your own access, please do contact us. They have a data curation team, and car.data@sydney.edu.au is the email address to get access. So in the instructions that Bill sent out, we asked everyone to be prepared to have R and RStudio installed. Now, I've been training a few different ways over the years, and there's always a bit of a setup phase for this kind of thing. And so to streamline that, I've put together this set of instructions in this web page and direct link to setting up RStudio. I'm assuming R would have been installed fine, but often it's this particular point here that is really important. What you'll see on my screen has the source code on the left and the results on the right, which is printed to the console. And it does get confusing if you're not seeing exactly what I'm seeing. So that's probably the only thing to make sure that you review. And if you're coming back to this later and you want to get set up, or if you've got new students coming through, they could follow that material there as well. So let's get on to the database. It has a homepage, which is also attached to the CARDAT GitHub website. And it's got a lot of information about the history. As I said, this is the first of its kind. There has been attempts. The states and territories came together with the Bureau of Meteorology a couple of times to put this together, but it was really when it became the most important thing for the health researchers to have access to national data, that we all had copies of different data sets. And when CAR, the original Centre for Air Pollution and Health Research, came together, we realized we all had copies of the same data for different parts of the country. And so we put them all together. We got a lot of help and assistance from the departments who own and create the data, and a little bit of funding from the Australian Research Data Commons has gone into building this amazing resource. You can see we keep it up to date. It's now got data recently uploaded, and what we do is we wait for the validated data to be completed. There are near real-time sources of air pollution data in Australia, and they come straight off the instruments. And they often need to be quality assured and quality controlled, checked, and can undertake cleaning and changes. And so you can see this database is always lagging in time. We also have a collaboration on a national near real-time API, but that's for another day. This is the stuff that's already been QA, QC checked. And so that's the kind of purpose that it's aimed for. It's also only the regulatory monitoring network and a few associated high quality monitors. We don't have any low-cost sensor data in here yet. And when we do, we'll keep them very clearly different, because what we wanted to do was have very high quality input data for modeling. And so we also built this GIS system where we can connect the monitor data to the land use data. And we spend a fair bit of time worrying about database design. And this is the result. You can see we've got, as I said, all of the regulatory monitoring and a few associated products. And we can zoom in on this metadata. And I live in Perth. You can see this particular site here. It's quite interesting in North Perth. Please note that this particular diagram is only here for information. These coordinates have been modified to protect confidentiality. And so I'm changing my screen now to show the actual map that I've got in my GIS. And I hope you can see that on the left, I'm connecting directly to this server, which has all of these other layers that are related to modeling air pollution, such as land use and satellite data. And these coordinates are the real coordinates coming straight out of the database. And you can see the difference. This is a particular site in North Perth, well situated to capture ambient background air pollution. And so when you're looking at this point, that's only for indicative reference. That's a bit of a important point for modelers. And so the coordinates that we get are double checked against Google Earth. So moving on to other things, this page is really good to get a feel for what's in the database. You can see the first table here is for temporal coverage. And I'm just going to show you now that PM 2.5 is one of the the really interesting pollutants. We've got hourly data all the way up until the end of 2022, and some we've started collecting more recent stuff there. And in Tasmania, we only receive daily data, but everything's up to date to 2022. You can look through the range of pollutants and other things. There's wind, there's radiation, rainfall, and so on and so forth. We've standardized to UTC and explain how to operate across the different time zones. We've standardized to common units, which is very important in doing a national analysis, and all of this metadata here. We've also been working very closely with the EPAs and other agencies in each state and territory, and because they own the data, we have this agreement to publish the data with these conditions of use, which that's why we enforce people having to ask us for a username and password so that they agree to those. There's all these resources. There's a wiki and some discussion that we undertake when we are looking at the data. Sometimes there's what we call inconsistent or curious observations that we question, especially there's a tendency for some observations to be negative, which is sometimes confusing. Sometimes it's valid, sometimes it's not. And so we do a little bit of extra checking and note these issues, but essentially it's buyer beware. Now, that's the introduction to the database. And the Hacky Hour is designed to give you a bit of a sense of the actual using of the database. Now that we've got this API, we're focusing on the API. And I thank you for putting into the chat, Cass, the links. And I would invite anyone in the audience to also post any questions into the chat, especially if you're having any issues with your RStudio setup. Cass will be able to answer you and guide you in the chat. So before I get onto the API, I'll just talk to you a bit about the past use of what we call DB connection, database connection. And you can see this kind of code that we write in R connects directly to the database and allows us to write the database language in SQL. And this is very handy for geospatial questions. As I said, you might want to extract the land use within a couple of 100 meters of each monitoring site as a predictor of air pollution. You can process the data server side, and then you can get daily averages by asking the server to give you daily averages. It's very handy to do that kind of thing. But the API is really for people to just download chunks of data that they're going to work on with their own GIS or doing their own time series aggregations. So this is what an API looks like, just in its native format on the web. It stands for Application Programming Interface, and when you expose that API to the web, you can show it like this, which, let's look at what we've got. Now might be the time to invite you all to learn your username and password. So to operate this first function called list air pollution monitors, all I need to do, I could specify the state or the format, but all I really need to do is say that the username is visitor for today only, and the password is visitor. And executing that gives us this not really human readable output, but that's, you can see a list of all the air pollution monitoring stations, altitude, latitude, longitude, and other things. Now, we use R to interface with this, and so I'm going to now invite you and show you how to go through the setup of the API key. And we have all these things on our CARDAT GitHub page. We have a range of different projects, but anything that starts with dat/sci-train is designed for us to give you training in data science. Now, in those instructions, you can see how to set up Git and GitHub the most effective way that data scientists use. If you're not doing it that way, you can easily just click on this download zip button and it's going to download to where I choose to put it. I've got this folder under my projects folder where I'm storing these things. So I invite you to put that there and open it up. Please extract it with the right spot. Now, what I've got here is the RStudio project file, rproj, and a few bits of code that will do the job. Double-clicking on that rproj file, if your computer is set up correctly, will open up R and RStudio. And if anyone gets this kind of update available, I generally ignore that. It's not that important to keep your RStudio up to date every time it changes. These kinds of things change a lot. So in this small demonstration, we've got 3 steps. We're going to start with creating the API key. But to do that, we're going to need to install this package of tools that we've created for NAPMD, which we host on GitHub, CARDAT NAPMD tools. You might not have dev tools. So what you need to do if you don't have dev tools is go to packages. Now you can see I'm clicking on the buttons in the bottom right-hand corner. I've gone to Files, Plots, Packages, Install. Write dev tools there and you're away. That might take a little while to install on your computer if you haven't got that already. Mine's here, so I load it and then I install the NAPMD tools library. Here's some more setting up and configuring information. A lot of things in the R environment can change. And so in this case, the curl package has been updated. I'm going to ignore that. This isn't exactly a hacky hour about using R, but R is so embedded in the way that CARDAT operates across the Centre for Safe Air and WHO Collaborating Centres activities. I think it is worthwhile just making sure that everyone can see what the approaches are that we use to keep things ticking along. So that's the latest version of NAPMD's tools installed. I load it and then I run create API key. And I was hitting Control Enter if anyone's not aware, but you can also click on the Run button, which is up the top there. Now, as before, visitor is the username and visitor is the password for today only. Gives us this message that it's created an API key. It's actually gone ahead and created this private folder to keep that API key. And it's also added that to this file called gitignore, which means that you won't be unwittingly publishing that to the web. Now moving on to step 2, the API demo. I'll hit run, loading the API key and running the first function, which defines the stations. It goes and gets the stations for New South Wales from the API and creates an object called stations, which we can see in our environment down the bottom. It's not called stations, it's called the abbreviation STNS, which I can visualize as a data frame. These are the actual latitude and longitude with altitude where available, classifications, and so on and so forth. Very useful to have that for spatial analysis. And then I was looking for this demonstration at a particular station. I chose station ID 453 And in our language, we can name that object, which is a data frame, and then we can specify which variable from that object to question. And I want to know, what is this station 453? It turns out it's in Western New South Wales, a town called Tibooburra, which is the back of Bourke. And so for this example, we'll continue to go ahead and run that function, which is get the times that are available for Tibooburra. And for PM 2.5, we can see that the earliest PM 2.5 available from Tibooburra was in 2019, and the latest one is the latest update that we've done, 2023. So feel free to change that. Go and look at your own state. Go and look at the station closest to you. There are different ways to query where the closest station to you are. Obviously, that works most easily in the GIS part of this database. None of these functions are particularly spatially orientated, and so if you're using it this way, you have to then go and run this in your own GIS. So choosing Tibooburra's PM 2.5 for the entire period 2019 to the end of 2019, I might change that to 2022 now that we've got the data here. And remembering that this is UTC, so you have to change that to the local time yourself. And it's gone over the time interval that's allowed. I think it's set to only allow you to do 1 year at a time. Let's try an exact 1 year period. No. Cass, do you know what I've done wrong?
No, it's the start time year.
It's within a year, is it?
No, you just need to change the year on that start time UTC.
To 22.
21.
21. And then that'll go to the end of 22, will it? Nope.
Well, the start time, you can make it the 2022-01-01. At the start time, not the end time.
Yeah, okay. So by trial and error, you can figure out how much the API will actually deliver to you in one go. I'm going to try this. Is it, Cass? All of 2022. And you can see I've got the data and I've printed it to my screen. That's unreadable. So I'll open up this data viewer format. Here's the data with Tibooburra's date in and hour in local time, and the date time UTC variable, which we've created for you. The units, the measurement method, these vary not only across states and territories, but also within monitor time series. And we've got the ability to track when we do updates and if we do any of our own validation and changes there. So that's really the guts of the system. We've got a function for getting a slice, which is to get all of the monitors available for a state at a time period. So rather than going one monitor by one monitor, if I run this one, it will get all the monitors for that time period. And I won't print it to the screen. You can see that's the thing that we wanted as advertised, PM 2.5 for all New South Wales stations on this date and time. Now, that's working with the hourly data, right? We have a range of data sets that are only in daily format, especially for Tasmania. And so that's when these daily functions are most appropriate. So for station 300, which we'll check out where station 300 is, just interacting with the data as I go, interactively writing the code to scripts when I need to. We must have a different table for the daily stations, do we, Cass?
No, it should be the same.
Station ID equals 300, not working. But we did get variables for that station and times. Get the slice. So this is the daily slice for Tasmania. And I've printed that to the screen. So I can just go through here and find out that station ID 300 is Had's pen. And as before, this will get a time series for all of those, for all of the times available for that station 300, called that OBS. And we have a time series. So let's put this learning into practice. Unless there's any questions, put them into the chat. Things should be working. And you should be able to check out ways to look at your own patch. Use this for your own research. The conditions of use are that this should be for research, and any researcher who's a bona fide researcher can get access to this just by agreeing to the conditions. It's not for consultancies and major assessments of corporations. The EPAs do that themselves, and so if you want to do that, you need to go and talk to the agencies. This little script has been designed to grab a particularly interesting day known as the Mother's Day fire smoke event in Sydney, which was in 2016 and was a particularly bad smoke exposure event that we've studied in our health research. And so it provides a bit of a case study. And so what I'm going to do with this final script is actually create a place to store this data that I've extracted and write that as a CSV, which is just some of our recommendations for ease of use to make sure that you've got access to the data rather than just downloading it from the API every time you want to use it. Download it once, check out the news updates, and if you're a user, you'll get emails if there's any major changes to the data. But realistically, you should go ahead and create your data download and put it into a data folder like I've done here. And we're going to use that in the next session of today's talk, which is about doing a spatial analysis using that data as the example. Okay, so just check my notes. I had thought when we were talking about the spatial analysis part of the database to show you this site again. And the great thing about having the NAPMD alongside all the other post-GIS data that we've got, you can see we've got geoscape data there, impervious surfaces, NASA satellite imagery, all of these ABS layers. And I've just turned on the ABS land use layer as one example. And so this is really important for the kinds of spatial regression models that we fit. That I wonder if I can also show you roads. Got traffic load here. And so it may just take a little while to talk to the database, especially if you guys are all using the database as we go. But this kind of interface gives me access to so much more than just the air pollution monitor data. It's a full predictive analytics suite, which isn't talking to me at the moment. Okay, so that's pretty much spot on time for the first half of the session, which was the setup and using the API. Yeah, that's not going to talk to me fast enough. When using GIS and big data, you get used to looking at your screen taking a while to refresh. So you can keep track of where I'm going to if you went to this. You can see we're now going to move on to this spatial model section. I'll talk about this for 15 minutes or so, and then finish with a 10-minute wrap up. So going to DAT-Sidetrain spatial interpolation with Kriging, I'll invite you to download the zip file again, as you did before. And I've already got it hanging around here, ready to go. I unzipped this one and tested it out before. Here's one I prepared earlier. Now you can see, again, I'm laboring the point for people who are used to working with this type of software, but in getting everyone up to speed, the R ecosystem is full of packages and they're not all installed by default. So here's a package I've intentionally removed from my system so that you can see it's inviting me to install the data table package just by clicking on this link here. Alternatively, I showed you before, the packages pane of RStudio will do the same thing by clicking on install. But whenever you get a script like this one written by someone else and handed to you, RStudio helpfully goes and says, well, you'll need a data table and anything else that you're missing. I click that on one. Maybe I do need to run the update of RStudio, but in the interim, I can quite easily install it using the package manager. Okay, I've got a warning here. This is also a really good training exercise for people new to R. You do get warnings. This warning is somewhat decipherable that the old package is being used by one of my other RStudio instances and so cannot be reinstalled. And you know what? ChatGPT gets a lot of bad press these days, but it is incredibly useful for explaining warnings that you get from R or RStudio. So I've closed all of those things. And I'll try that again. And voila. So in this little package we've put together, we've got some provided data, a spot to put your derived data that's currently empty, and this initial script of how to do a Kriging model of hourly data. Now, to motivate this case study, I'm going to show you this little couple of slides I put together. It's really to do with the demonstration of NAPMD, but it was originally something that I put together to look at the spatial attributes of the black summer bushfire smoke in Sydney. And we did this really quickly for this Medical Journal of Australia letter that we put together really rapidly. You can see it was published in February, but we were working on it in January over the summer holidays because that was such an amazing and thought-provoking event for Australia. And one of the recommendations we put forwards in this paper was that people have more access to air pollution data, thinking that researchers and the general public could really benefit, especially having hourly data. This plot here is the hour by hour citywide average, and the grey lines behind it are certain places at certain hours. And I was able to do this rapidly by getting the data from the New South Wales government's website. And now we've got this NAPMD, we're able to do this with the high quality data for everywhere in Australia. And as I said, maybe later next year, we'll talk about the near real time API that's available as well, and apps that are using it, this to give phone messages. And all this has been enabled by the kinds of data science that I'm showing you today. So that GitHub repository that we've downloaded has the code to do what is called a Kriging model, and compare that to an inverse distance weighted model, or IDW. You might see these terms printed in various different studies. And I won't give you the full details today, but like I said, we do training, and we have a program of training for data science. So this script has a blurb at the top with what you should expect it to do. It's loading the packages that it requires. I've sorted out the issue with data table being missing. All these packages are available. And so we just run through thinking about what we're going to do in this particular study. We're going to load up the particularly interesting hour for the Black Summer in Sydney. We're going to create these GeoTIFF output files. We've tried to make this as generic as possible so that we could run this on different data sets with different names. Sometimes it would be the full name latitude. In this data set, I know that it's actually been abbreviated to lat. We might want to do it on different response variables. In this case, it's PM 2.5. And I'm setting up the Sydney region here by giving it a bounding box. So that's where we'll predict the air pollution in between the monitoring stations. Reading the data and converting it, doing some visualization, exploratory style. You can see the general shape of New South Wales there. I've printed the data to the console to check it out. Indeed, it's all of New South Wales. And looking at the structure so that I can then, this is mostly important for the people who wrote the code to understand and to develop the project. And then now you've got this code, you are also aware it's fully transparent what has been done and what the data means, with comments that specify what you should be aware of at each point. So we're going to select parts of the data and make it fit our study region. So we're cropping it. We can see a warning here. It's not an error, it's a warning, so that's okay. It's just saying that we are assuming the coordinate system or projection to be constant, which is a good thing to assume. And a quick plot, not the most beautiful plot in the world, but this shows a high air pollution cluster in the center of the city. That's the shape of Sydney. We'll talk about that in a second. So moving through, Kriging is quite a complicated mathematical algorithm, and it's made a lot simpler by this R package auto map, and the function is auto fit variogram. And so when we use this, it gives us an error. Okay, this is something I'm going to need to debug. Coercing spatial to data frame.
And just run it from line 60 again.
It was working before,
60.
wasn't it? Hey?
From line
60.
60. Yeah.
Oh, because it was a... So you've got to be fairly resilient with R to warnings and errors, and have a friend like Cass who can spot where you've gone wrong. That particular thing there is what the Kriging model needs. If you didn't have auto-fit variogram, you would have to figure that out empirically, which is fun and interesting to do. That's what we get trained to do in geography. But now I'm training a whole bunch of different disciplines. We have these amazing toolkit, and this package GStat fits what we want it to do. In that one, I think it's done the Kriging. In another one, it'll do the IDW. Here we go. This one does an IDW. Tells us what it's doing as we go. And this one will actually do the predictions from that Kriging model, which uses all of the relationships between all of the spatial points and their distances. And it can be used the direction, and it can also be used to add predictors. So co-Kriging is a thing. That's finished now, and I'm going to turn these into a thing called a raster. Visualize them on this. You can see IDW is very sensitive to the data because it's basically whenever you get to a data point, its distance to that data point is very small, and so the weight given by that data point is huge. Kriging, on the other hand, is using a general statistical relationship amongst all points to give you what it thinks is the best spatial model. And then writing those results out to geotiffs. Here's my QGIS all ready to go with the first IDW layer loaded up so we can have a look at what's going on. So we can see from the NAPMD, I was able to extract the PM 2.5 for Liverpool and set the resolution, fit the model, export the geotiff, and potentially use this in a study. I've got a little bit of time, so I'll load up. I'll show you how to load data. There's a data browser. This talk isn't about QGIS, so I won't go into detail with this. I'm going to show you the Kriging model, which, as you can see, is much smoother. And we can copy and paste the style so they have the same color ranges. And depending on what kind of extra steps we would take to validate these models, we could get a performance measure and figure out between those two, or change the settings, which of the two performs best. But that's for another day. I'm going to finish off very quickly this example with a quick talk about repeatability and reuse of data. And this Mother's Day event that we were talking about before. This was a paper by my colleagues from quite some time ago now, but it was used this IDW for the Mother's Day event. And so you could easily think of an interesting case study to go back and remodel some of these well-known events and see if we could improve the. So this was essentially doing an IDW and then estimating the smoke-related concentration as the difference on to the non-smoky days. The smoky day concentration is the difference with the non-smoky days, and that could have a big impact on your assessment. So that's now able to be done by essentially changing a few lines of code in this demonstration. So I've got data that I just recently extracted and stored here. This CSV file is the one for 2016. So just as a really quick demonstration, I'm going to move it into the provided folder for this project. Data derived comes from one project. It can be provided to the next project. That turns out to be a really neat conceptualization of data science workflow. Now, what I'll need to do is now change the name of this CSV to that. I'm going to change the output manually, call that, it wasn't a bushfire, it was a prescribed burn. Prescribed burn 2016. And then everything else presumably will run. As it flashed past, I saw a warning. That's fine. So I'm just running this entire thing now. You can see that once you've set up a pipeline, you spend a fair bit of time getting your data correct, making sure you understand its attributes, cleaning it, set up all the analysis. And if I wanted to do this for a different part of the country or a different time period in Sydney, it's as simple as putting the data in the right spot and running the codes again. So now I'm going to switch off the Black Summer.
I think you missed running the in file assignment in the scripts.
In my enthusiasm. So if I hit this source button at the top, it will do everything. And my Jiminy Cricket Good Samaritan on my shoulders, Cassandra, has double checked my code. Good to go. Source the script. Okay, so this is the data browser. I'm going to go and select this prescribed burn day in IDW. Add that. And I'll get the Krieg at the same time. Because I've copied that style, I can, oh, it's gone. I'll copy it again. All using the same style makes the color ranges comparable. So it's much less than what happened in the Black Summer. And IDW has a you can't really see it, but if I vary this, like that, you can see this is now getting closer to what my colleagues modeled in this way. They also assigned those to ABS statistical geography. You can see these are called SA2s. Those stand for small area level 2 polygons. And we could add those by, in this case, going to the online database server and grabbing them from here. So I consider that part of the NAPMD. The NAPMD is really housed within this air pollution schema of the database, which is just sitting there next to the ABS data, the CS-CIROS data, geoscape data, NASA data, and roads, 2 different sources of roads. So we've hit the 50-minute mark, which was my plan. Going back to the schedule, we've now got 10 minutes set aside for wrap up and Q&A. Any questions? And because this is a hacky hour, it's designed to give a fairly communal and collegial experience of coding. I hope I've shown you that a lot of things can and will happen to you while you're spending your day coding, and not to think it's too hard. It's actually it's hard because it's good. It's better to go through a bit of that pain because it means that you sort out issues, you debug, and you make it transparent and repeatable. Okay, so keeping an eye on the chat. Cass, have you noticed anything that you thought I'd say that I didn't?
No, I think you've covered most of it.
Great. Well, we can um, see how long it takes to load up the roads layer. Razia's got a question. Are the numbers shown in the Krieg model micrograms per cubic meter? No, they are the natural scale of the input data in that case. It's really that bad when you have a bushfire in Sydney. On an hour by hour basis, right? Maybe can we double check the scale of the units in this lot? Yeah, that's up to 600. So the model's estimating even higher than that, or potentially the data that I got from the NAPMD went up to 700. But you can see that in this publication that we made just of these data, we were up to 609 in Western Sydney on that day. So that's showing up here. Get rid of Mother's Day. Querying the data. QGIS is incredibly useful for interactive exploratory data analysis and quality checking. It's actually Liverpool is up there at 700 something. And potential, that's a really interesting observation. Thanks, Razia. You can see the difference between that you get over time. So at some point, potentially Liverpool, which I'm guessing is not on this map that was published in February 2020. That one there. And maybe because it was withheld by the data custodians until they'd validated it. In fact, going back to that period, I was working on this paper during January. I ended up going back to the New South Wales government website 3 times to remake that map because I knew that the data would be changing, and it did change. I went 4 times, got the data 4 times. I only needed to go 3 times, but it's a good point that I think a lot of people who are using the near real time data aren't really taking full account of, is that you should go back if you want to find out what's been verified and changed. And so that was what the NAPMD provides. We only ingest stuff. Oh, there's a hand. Adam, hi, how are you?
Hi, Ivan. Great. Thank you. It's an awesome presentation. And it's great. It's a great looking at our package as well. So I understand, like, yeah, if you request access to the API, you can get the monitoring data. If you put in a request, are you also like granted access to this PostGIS database? Like, so
Yeah, we offer.
So I mean, yeah, I know this. A lot of these layers are from you've just collated, and like we at EPA Victoria have some of them as well. But it just looks like another handy tool, having them all in one place, like the land use and so on. So, is that yeah?
It is handy.
Is that accessible as well, or is it just the API?
It turns out, well, so there's 2 answers. The
Yeah.
first answer is yes, you can request access to any of this stuff,
Right.
but some of it is under license, and we can't give it out under certain conditions. So, for example, the ABS data, no worries. The roads PSMA, no worries.
Yeah.
The roads Street Pro, no. That's
Okay.
only the license for a single kind of project.
Yeah, I see. Okay.
Because Street Pro and PSMA offer different types of roads.
Yeah.
So the best way that you can find out about that is to go to CARDAT's data inventory
Ah, yeah. Okay.
Here, there's a button to access the data, a request form.
Yeah.
And so you find, so let's look for Street Pro. We got it. I believe it's the 2013 one. Access is restricted to that one.
Yeah.
So, but our data curation team can help you. They can say, well,
Yeah.
but have you considered this PSMA transport package, which Luke downloaded and also requires permission. But I think potentially we got this one. No, roads are a bit tricky. Let's put it that way.
I understand. No, that's fine.
Yeah.
Thank you.
The other answer that I wanted to give you was it's actually a great idea to have everything in a really big database, but it's not that usable for people who don't have a huge affinity to databases.
Mm.
And so a lot of the underlying work that my team of GIS users did last year was actually with the raw data on a file server and using R and different Python packages to do the work and different GIS packages. PostGIS is a bit of an acquired taste, but having it there and using spatial SQL queries is in theory a really good thing.
Yeah.
But actually it's fallen out of use. I'm probably the only person in the team who really enjoys working with spatial SQL.
Okay. That's all good.
And if you are,
you got a friend
you
down
are
here in
like me,
Victoria, so yeah.
got a friend. Well, that's the other thing that we've got on this appendix. You've got this link to the API, and then you've got a few different explanations about how to do
Yeah.
the SQL.
That's awesome.
Well, that's brought us to the end of the time that we've allowed. Stay tuned for more Hacky Hour, supported by the Centre for Safe Air and the World Health Organization Collaborating Centre for Climate Change and Health Impact Assessment. And with that, I'll let you get back on with your day. Please contact that email address, car.data@sydney.edu.au for any of your data and science needs. Thank you.